Welcome back to Thinking with Objects, lecture number 2, classes, packages and scope. So this lecture, what we've discussed already, is, well, more advanced things that we can do with the classes, some keywords, this and null and a few things like that, how they are meant to be used, so a few more advanced things. But this example here that I'm still working on, it's a game, and it's there for you to be able to grasp better why to use objects, why it's good to have objects and classes. So there's no reason to learn how to use things if you don't get when to use them, because then you will never use them anyways. So what we've seen so far is that we have a player here. If I go to the correct scene here, we have the player here. We can move the player, and we can have the player at a specific health, a specific location in a specific map. So we have a map here as well, and that's a board of a 2D array of locations here, which we can have two things in. We can check if they are well, the symbol we want to print it out with, and if they are solid or not. So if we can move that, and then we have the actual game here. But like you saw, we had health here, right? So that's what I'm going to implement next. I'm going to allow location to damage the player. For instance, if there's a mine there or something like that, like it explodes, you know. So what I want to do here is location set damage int value and save it. And I'm using the location here as well this time to be able to chain these together. And now we will actually see a proper example of how I can use that. Return this like that, and then of course I might want to do something like if damage is not equals to null, so that we have a damage here. We want to deal a damage when the player arrives. Then we would tell the player, well, you just got damaged, so decrease health, and with the specific amount. So it's better to do it this way around, rather than just to get the player's health, decrease it by the damage, and then store that new damage, the new health as the player's health. And what that is going to do to us, because we do it this way around, is if the player has some specific armor, if the player has something that decreases the damage, then the player can take care of that. We're not going to just directly assume that health minus damage equals the new health, which is going to be the case, but if we don't assume that and ask the player itself to decrease the health, then some more advanced things might happen. For instance, if the player has some armor. So therefore I'm going to just write the void decrease health here, and finally the damage, like that. So now we can ask the user to take some damage, and hopefully the user will be damaged, because, well, we're told it to do so. So reduce the health with the current damage, but we also might want to check, like, if the user is dead. So if the user died, then we might want to print out that the user died. So as you can see here, I'm not doing too much special more than just decreasing the health. But like I said, one could do like, alright, that mine just critical hit you, so we increase the damage by 2, and then we deal the damage, you know. So some more of those things there. And how do we check if the thing is dead, if the user is dead? Well, we just return if health is less than or equals to 0. Sweet. And finally, we might want to be able to get the health of the player. So we do get health, and that's going to return the the current health. And now we can use that. And I can't spell decrease health. What? And I can't spell void. Okay. Never mind. There you go. So now we can use that in this example. So you might have guessed something here. So when do we want to loop this? Well, we want to loop this as long as the player is not dead, so an exclamation point there. So we loop while the player is not dead, and when we do so, we print out the map and we move around until the player dies. Okay. So far so good, but we might want to print out the amount of health the player has, so we can see that. So current health, and then the player.getHealth. But well, we don't have any mines in the map. But just before the break, I created this thing here. So set location. So now we can set the content of a map, of a location there. And I'm going to make the map bigger, first of all. Remember that we had the constructor here, using this one here, to create a default size map, 10 by 10, but you can also specify on your own the width and the height of this specific map, which is what I'm going to do to make it bigger, to get room with some other things. Right, and what we can do now is we can create a new mine location and then place that inside the map. So map.setLocation 55 new location, and the symbol need to do, and then I can set the damage. Set damage 3, something like that. Can find symbol set location. So let's see. Well, that didn't work. That locate. I can't spell today. Sorry about that. Okay. So now what's going to happen now is that we create this new location with an X symbol. So that's going to mark how it looks like on the map. And then I set the damage. But here's the chaining thing I spoke about. When we use set location here, we need an integer, and a location. Since set damage is returning a location, up here, we return ourselves. Since we do this, we can just very easily just put it like this one line here. Otherwise, we would have to do like location, my new location equals new location, X, and then we would have to, on a separate line here, do my new location dot set damage 3, and then finally just refer to my new location inside here, because we wouldn't be able to do just new location dot set damage if it didn't return a location, because then it would try to use set location using void. So just because I'm using that little trick there, and I'm not telling you that you should do it all the time, but when you need to, and here's a very good example where we want to set the damage when we just create a new location. So therefore I return a location here. It's just a way of chaining them together, and since I have solid here as well as one of them, I can do like set solid true, for instance. So it's totally fine to do something like this. But the problem with this is obviously that if it's solid, then we won't be able to go there, and therefore we won't be able to take any damage. Okay, so let's compile this and run it. Here we go. So let's get some more space. So all of a sudden we have the current health of 10 there. Can barely see it. And then we have this bigger map now. And if I move down there, and that was the wrong one. Here, you will see that I took 7 damage, right? But I can continue to take damage. I can go back and forth until I die, and now the program is over, as you can see. But it doesn't really make sense to be able to allow the mines to explode multiple times. So what we could do is to remove them like this. So if it deals damage to the player, then remove it, and finally set its symbol to being nothing, like that. So now it's going to work a bit differently, because now it will only be able to damage us once. So I can move to the right, if I have that selected, right, 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 and finally I can go down, and now it's gone. So all of a sudden we have a dynamic map, so the map is changing depending on what we do. So that's pretty nice. And furthermore, what we could do is to add some more mines actually. So I'm going to add 2 more here. There's no reason to just type them, so I copy them from my example there. So at another location I have 20 and 5, and that's going to deal 10 damage rather than just 5. We can actually use an uppercase X there to mark that it's a bigger one. And then we have another one at that location. So if we run it now, we will see that we have a few more here, and they will work exactly the same. So as you can see now, just because we wrote the code of dealing damage with a mine, then we can just add a mine as simple as this, instead of having like, oh right, if you step at this specific location, if you step at this specific location, or if you step at this specific location, then you should take some damage. So it's very easy to just expand this. We can just add another mine with one line like this, another mine, and so on and so forth, and just change the damage. So it's very easy because we have a class called location where we can set the damage, and then our map is built up of these locations. But well, if we can get damaged, why can't we, well, teleport? Teleporting is nice, right? So what I want to do here is to add something else. So we can set that it's solid, we can set that it is has some damage, but I also want to do and set warp zone. So this might sound a bit ridiculous. Why would I do something like this? But you will see. I'm actually going to use this warp zone thingy to show a quite nice thing about classes. So bear with me. And what do we want to do? Well, we want to say warp to map equals map. So that's a field I will have to create. Warp to x equals x. Warp to y equals y. And then I can create those fields up here. Warp to map. And then we can do int warp to x. And finally int warp to y, like that. Right. So what happens? Well, if we step on a location here where we have our map not being a null, that means that we have set the warp location. And to answer a question in the chat, the font is so big so you can see better. So if we have somewhere to warp, so we have warp to map, is that not null? That means that we have somewhere we want to go. We have actually set the warp zone to something. And then we can just tell the player to warp to map, warp to x, and finally warp to y. So now we're telling the player to warp to a specific location. But well, we need to create that method as well, right? Yeah. And it's pretty straightforward. Void warp to map int x int y, and then we just want to save these as the new values. This.map, so we use this here to refer to the field with the same name. This.x equals x, and this.y equals y. For some reason I recognize this part here. I recognize this.map equals map, this.x equals x, and this.y equals y. I even recognize the whole thing as a chunk, all those 3 lines in a row. Well, I can see it here, up here as well. So what we could do is basically do this. Warp to map x, y. So when we create a new player, we define a map and a location, and that's where we want to like warp to in the beginning. That's our spawn point. So now I'm just reusing the code here, so I can warp to a location from at any time, or I can use it when I create the actual player. Of course I can do other things. I could have like the health here equals 10 if I don't want to have the health up here as the default value of a field. Like that. So warp to map xy and then health equals 10, like that. So now I'm just reusing code here because it's the same. We just set the map, the x, and finally the y. So now we have warp to, and then we have set warp zone. So we might just as well use it. yeah, if I want to chain these things together by having a location like this, then it might be good to actually return the location. So I forgot about that, and therefore I got an error. There you go. So how do I set the warp zone now? Well, we do map dot set location, because we want to set a specific location, and I want to do that at 8 and 1. And then I want to use new location. We want to create a location. My warp zone is going to look like a big circle. That's fine. And then set warp zone. We want to teleport into the, on the map, and then we want to set 12, well, 15 1. So I'm just going to move from 8 1 to 15 1 instead. Like this. Okay. So all of a sudden I have that over there, the warp zones. If I move to it, like that, I'm all of a sudden going to appear here, and that's at the location 15.1, right? Seems all right. So what's happening is that when we arrive, we realize we arrived somewhere where we have a warp to map. We have specified where we want to warp to, and therefore the player will warp to that specific location, and that's exactly what's happening. But it seems a bit weird to just teleport us a bit further, and even if we went back, it would teleport us there again. So that's just a fixed location where we teleport. There you go. But I'm going to use this, like I said, to show you some very neat things that we've done. Well, we've used the map, like our map, but it doesn't really do much, right? We have a lot of neat things we can do. We can print out the map, we can create open map, we can set the location, we can get the location, and create it with a width and a height. But the only thing we store is actually this board, a 2D array. Why would we just not have? We can just have that 2D array here, right? Like location, board, and then we don't have to create this map. Well, that would cause a few problems, but we could fix them. But, well, what if we wanted to have multiple maps? That's totally possible. So, all of a sudden, I'm going to create a new map, a house, new map, 9 by 9, and then what I want to do is to warp to the house. I'm going to move that up a bit, and then I'm going to warp 4, 7. So if I do it like this, right, what I might want to do is to actually, I'm going to move it down here, but what I might want to do is to actually tell it to create an open version of it, otherwise it's just filled with nothing. So create open map, like that. So I have the house, and then I create the open one there, and then I set the warp zone to go to the actual house rather than to, oops, that's supposed to be 0, rather than to inside the same map. So now if I do like this, I moved up the warp zone, so it's a part of the wall, so it's like moved to a new area. And now if I move up, I'll move to the right. Well, I can't move up here because the border is in the way. It says up there you can't move there. But if I move over there and move up, boom, I'm in this house. It's quite empty, but I'm in a new area all of a sudden, and I can just move here. So that easily I just created a new map because I had a class called map, so I could just create a new one, and using the warp zone thingy I could warp to another map. And since we're not printing out a map, what do? We print out the current map of the player. So therefore when we change the current map of the player, it just started to draw that one instead. So let's add a warp zone back to the thing, to the bigger map, the thing outside the house, and that's going to go to 8 1. Oops, that's the wrong thing. I wasn't supposed to hit test. Crap. Here you go, run. Right, so now if I move Yeah, I need more location for that. Oops, more space. I'll move right here, and finally I'll move up like so. So now all of a sudden I'm in the house like before, but well, I can go back through this doorway. So that's just a door. There, it didn't work. Why didn't it work? Well, I warped where I was supposed to, right? I need to warp to the correct map as well. So we warp from the map to the house, and from the house to the map, not from the house to the house. That's not going to work. So everyone can do the mistakes. So let's see. Right, 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 right. There you go. And then just move up into the house, and finally move back. Fine, it works. Nice. And to note here, I'm not creating a new version of this. So for instance, if I go to the left here, I take damage from the mine, and then I move up and go into the house like this, and then I head back, then that mine is still gone because, well, it blew up. We create one map, basically called map, that's the bigger one, and then we have one called house, and these, well, they are both there. It's not like we remove them, it's just that we have one that the player is currently in, and that's the one we're drawing. So we draw the house, we draw the other ones. And what we can do is we can add things to the house as well. So I can add, like, I'm going to add a health pot like this in the house. So we type house here, house.set location, and use a H here, set the damage to -10, so you take a negative damage, and then finally do 4, 1. So as you can see, it's very easy now to just construct these things. I added another map, I added a new health potion very easily, and that's sort of what object-oriented programming is all about. You create a blueprint, you create the class, and then when you have that, you can just create new instances of it. And therefore I created a map just this easily and just put things in it. I can go and grab this health pod. I now have 20 health, and then I can move back out again like this. Nice. Oops, you're supposed to type things. Of course, this is just text-based. There we go, 17 health. Of course, it's just text-based, so it's no good graphics or anything at all. We just print out the same thing here. We can check our history, like how we moved. But this idea is still the same. If we would add a graphics engine to it, we would just print it out, and instead of in the location here, instead of storing the symbol, we might store up here. We might store the image we want to draw instead, but the idea is the exact same. So right, this lecture is not all about classes. We've now seen new things we can use. We've seen this thing here. We have seen this, using this as that thing as well. We've seen where we can use fields like so. So we've seen quite a few new things. We've seen how to call constructors from each other. We've seen what null is, why to use it. We use it here as well. But the lecture is about packages and scopes as well. So it's important to talk about those as well. So a package is a way to sort of organize your things. And at the moment, the program is not that big. We have 4 different files. We have game example, location, map, and player. So it's not really that necessary to split it up into different packages to organize it all. But let's say we have 400 classes, 400 files. Then it might be a bit tricky to organize everything if we don't split it all up in different packages. So a package is basically sort of a subfolder where you can have your thing. So what I'm going to do is place the player here in a package. The package I want to place it in is unit. So you can place like players and mobs and everything in there. And I'm going to hit compile. Now it's going to complain that the file is in the wrong directory, because if I ask it to be in the package units, then I should place it in a subfolder called units. So if I hit save as here, and I have that prepared already, I have a units folder here, and I can save, go write the one that's already there. So there we go. Now it's in the correct folder, and everyone's happy, right? Then I can put Yeah, the error is still there because I haven't compiled. Then I can put these guys in package world, and finally this thing here in package. Oops. Package world. Like that. I get the same error for these. I need to save them, right? So save as in world. So remember, you need to name save a class or a file as the same thing you call the class. So we need to call it location.java, but you also need to save it in the correct subdirectory depending on which package it is in. So there you go. But now we get other errors. It tells like, all right, what's this map you're talking about? So all of a sudden we get more errors. How boring. Like this, for instance. Well, what's map? Well, the reason why we can't find a map, we have two different maps now. What? We have one. Yeah, that's the old one. There you go. Just close that. So we have this one here. That's in world, but while this player is in unit, so we need to import the map. So we've imported things before, but we have never imported our own things. So I can just do import world dot map, and we're also using location here, so we might need to know where that one is. So then we can do import world dot location. If we wanted to, since we're importing everything that we have in the world package, then we could do world dot star. That means that we import everything that we have. That's not good if you have like a huge package with a lot of classes and you're just going to use one of them. But in this case, we're using 2 out of 2, so we could do it like this. Or to be more clear what we're doing, we could do import world.map, import world.location. So if we have different packages, we need to remember to import those classes to be able to use them. We basically tell it where they belong. And I'm going to do the same thing here. Import units.player, and I don't have to import the location just because, well, they are in the same package. Import units.player, and finally, oh, I have an import here already. Yeah, so what I'm doing here is I'm importing scanner, and scanner is in the package Java, and in the sub package called util. So I could add sub packages. So I could do like units.playable, like that. So I have like all the different units in one package, but in that package I have a sub package where I have like the different players you can use, for instance. But yeah, if I would do that, then I would import here. I would import units.playable.player. But since I'm not using that, because I would have to save it in a subdirectory called playable as well, and there's no reason, so I just have one package here and then the class inside there, and then we need to import what is it? World, right? World.map and import world.location. So these two are in the same package, and that's in another one. Hit compile, and oh no, 38 errors. This is a very good thing. We have package and import, and now we get 38 errors. Okay, so the reason why we get 38 errors are scopes. So that's the last subject of today. Scopes. And scopes are basically where you can access your different methods, your different fields from, your different constructors. Can you create this class from this other package and so on? And we have 4 different ones, where public is actually one of them. So we have used a scope modifier there, a scope keyword, and we have public. That's the most accessible one, so I'm going to go through them from most accessible to least accessible. So we have public, then we have protected, then we have the default one, and then we have private. And the default one is the one we've used by not adding anything in front here. So we can add modifiers or scope keywords in front of these methods, or we can leave it blank and then we use the default one. And all of these 4 are different, but since we haven't gone through subclasses, which is the topic of the next lecture, I can't tell you the difference between protected and the default one. They do have a difference, but I can't tell you the difference because we haven't gone through that difference. So what I'm going to go through now is the public, the protected, and the private, and then we're just going to assume that the protected and the default one is the same, which it is if you disregard what we're going to learn about next lecture. So right, so if I here in the location one, I don't want you to be able to access the symbol, the solid, the damage, the warp to map, the warp to X, the warp to Y, because what I want to do is to, well, tell you use is solid if you want to get if it's solid or not, and the damage we're just going to use it here on our own. You're not supposed to get it. So what we can do is define these as private, and what private means is that you can't access it from anywhere outside this class. So we can't access them from our map, and alright, we still have all those errors, of course, so I can't run the code. We can't reach it from the map, we can't reach it from the player, we can't reach it from the game, but of course we need to get the values, and what we want to have is like public here. That's going to allow us to reach this constructor where we where we create this location. We can reach it from anywhere at all. We can reach it from our package, from another package, from the class. We can reach it from wherever we want to reach it. Right, then we have the third one, which is protected, and protected means that we can reach it from our own class, but we can also reach it from classes inside the same package. So when we get the symbol for the map, you're not supposed to just get it from anywhere, so I'm just going to restrict us so we can only get it when we're working inside the world package. So the map is going to use it to print it all out, but there's no reason for like units to access the symbol, because that's just a graphical thing. So that's to prevent us from actually using the graphical symbol for something else. So now we can reach that one in the get map symbol. So we can reach it from map, but not from player, because that's another package, and not from game example, because that's also another package. That's the default one. We haven't defined what packages should have. And then we can just continue and give this public. Oops. Public, so we can reach these from anywhere. So it's quite common to have these methods as public, but that's not always the case. And if I compile now, I just get 24 errors. So all these errors appeared because, well, the default one, like I said, for all we know at the moment, the default one and the protected one is exactly the same, and the protected one doesn't allow you to access things from other packages. And since I started to split up everything in different packages and had all scopes to be the default scope, well, therefore I couldn't reach them all of a sudden, therefore why I got all these errors from different packages with the default scope. That doesn't work. So that's why these errors appear. But what we can do is like, alright, this board should be private, you shouldn't be able to reach it from anywhere. This constructor should be public, this should be public, that should be public. So as you can see, I'm having a lot of public things here. But when you do more advanced things, it might be nice to have like private methods as well. So you have some help methods that help you along to calculate some paths. I don't really have that at the moment, but you could totally do that. We could have, for instance, we can like split this up and do print location, for instance. Well, not print location, board text, and then we do plus equals get location SHA, and then we send along the location. So then I could have like a private thing here. There's no reason to reach it from outside, so I do private void, what was it called, get location SHA, and then I use location like this. And of course we have get map symbol, but we also need to make sure that it's not null. So if it's null, then we return that, otherwise we return this. So all of a sudden now I have a private method, and I want it to be private because there's no reason for you to access it from any other location, but I'm using it here just to make things look nicer, so it's like easier to see what's going on. But otherwise, most methods in my example, and I want to stress that it's just in this example that most of the methods appear to be public and all of the fields appear to be private, and I just have one protected. That's just, I don't have too advanced code, so there's not too many reasons to do it anywhere any other way. But it's quite nice to have private fields here, so we can't reach them from the outside, and then we have public methods which we can reach. Did I screw that up? Apparently I did. Yeah, let's see. Map. Yeah, of course. We need to return a SHA and not a void. That's what you get for adding things you haven't prepared to add. So here we go. Just add these as public. So most of these things are just public things to add. So we can't change the location here directly because they are private. We can't change the health directly. But we can, for instance, we can get the health, so we can read the health because that's public. We can check if you're dead, that's also public, and we can decrease your health with a specific amount, and that's also public. But we can't just set your health to like your health equals your health minus 2 or something like that, because then we bypass this part where we change it. And yeah, and that's exactly what scopes are. We can protect our things. We can make sure that you can't access fields, for instance, directly. We can make sure that you don't do silly things. We might want to have a class that you can't create from the outside, and we can make it private, for instance. And then we might have a method in here, like a public static void create stuff. And then we can call that, and that one can create the player. That would be possible. But since we want to be able to create this class, well, instances of it from the outside, we want to have it public. There you go, no errors. And now if we run it, we will get exactly the same thing as we did before. So why bother, you might wonder. Yeah, so here I can go to that mine here, and oh crap, boom, you died. Right, so we have different packages now. So I import these 3 classes from different packages, and I define packages here. But like I said, since this example is so small, it's just 4 different classes, it might be a bit ridiculous to split it up in different packages, but you get the point, because, well, we have location and map here to define the world. We might have a lot of more classes that defines how the world works, and we might have a lot of more units. So when we get to like 12 classes, or like in that amount, all of a sudden it gets a bit messy if we just have everything in the same location. So therefore it's nice to split them up, but then we have to remember to import them, the ones we want to use. So we import units.player here in the map, and in the location we import units.player as well, but we don't import location in map and not map in location, because they are in the same package. In the game we import them all together with a built-in one, the java.util.scanner, so that's exactly what we do. And finally, in the player we need to import the map and the location. Then we use these keywords, these scopes keywords, to tell us where we can access this from. If we can access it from the from just within the class, that's the private one, from everywhere, that's the public one, or as we used here, protected, which is only from within the same package. Then we have the default one, which has a difference to the protected one. So the protected one and the default one has a difference, but to all we know at the moment, that difference doesn't exist because we don't know about it yet. So next time we will talk about subclasses, and then we will see the difference between them, and therefore I will go through it then. So that's scopes. So it's very nice, very useful, so we can protect our things to be used directly, for instance. And then what we've gone through more is, for instance, this thing here. We can call our a constructor from a constructor. We can handle null, so null means that we don't have anything there, and we need to make sure that we actually think about that, because if we refer to null, we do null.location, we can actually just try that out. So if I all of a sudden would remove that null check and just print out the location.get map symbol right away, then if I run the program, it would basically crash right away. Why is that? Well, we get a null pointer exception. Hooray! And that means that we try to refer to something that was null, and then we refer to a method of that one. So we can handle null values. So we had null in here, but then we can't do null.get map symbol, for instance. And the reason why we had, oops, need to run the correct one. The reason why we had null location was because, well, this border consists of empty spots, so we don't have anything in this border, and that means we can't go there. Or we could just create our border ourselves and set all of those to solid, because we have a method called isSolid. So that's that one. Then we can use we use that in player here, for instance. We use this down here to refer to a field with the same name as a parameter, so we can refer to that one, because otherwise it's being shadowed, so we can't see it, because we have something that is more local, this parameter here, that's more local, and therefore we're going to see that when we just use its name properly. So then we can use this dot map. And then finally we can also use this as well, we can send along ourselves. So when we want to move, well, move to is a location that we're moving to, and we want to tell that location that the player just arrived, but we want to tell it which player arrived, so it can tell the player to warp somewhere, or tell the player you took some damage, and so on. And to do so, we just refer to this, which is the current player we're using at the moment. So those are a few new things we've learned today, but most importantly, in my opinion, is to get a bigger example here, see what we can use classes for. As you saw, it was very easy to just create this new map. I created the house map, the 9x9 there, that we can just go up to here using the warp zone and get into, and all of a sudden we can well, we can be there as well. Then we can move back. And that's sort of the point. When we have the blueprint, when we have made the class, we can use it multiple times, and it's just easy to use. And that's sort of what I wanted to show you. Multiple classes working together, easy to create new objects, and use that in something that would make sense. Because the last example we had a die, last lecture, a die and a share, like why would you have that? Now we have a proper game, we have a location, a map, and a player, so it's a very simple game. And yeah, but that's about it for today. I don't have any summary images. I will upload them a few to the course page a bit later though, so you can check them afterwards, but I don't have any at the moment. And the questions and exercises document that we usually have is a bit delayed. It will be there soon, so that page will be updated soon after this lecture. I'm sorry for it being a bit delayed. I hope it's alright. So that's about it. This has been Thinking with Objects, Classes, Packages and Scopes. I've been VSWE, and I hope you've enjoyed it.